A fireball tears across the night sky west of Berlin. People film it on dashcams. It flashes on doorbell cameras. For a few seconds, the dark turns green and white, and then it's gone. Thousands of people saw it. Almost nobody realized what had just happened. Somewhere out in the frozen farmland, pieces of a rock that had spent billions of years drifting through space were now lying on the ground, waiting to be found. And within hours, a scattered group of scientists from 4 different countries would start racing to reach them. What they eventually pulled out of those fields would turn out to be one of the rarest kinds of meteorite on Earth. Only about a dozen like it have ever been seen to fall. This really happened in January of 2024, near a small village called Ribbeck. The rock was given a name before it even hit the ground. They called it 2024 BX1, and that's the part that shouldn't be possible, because almost every rock that has ever fallen from the sky arrives as a complete surprise. 1 second there's nothing, and the next there's a streak of fire and a rock buried somewhere in the dark. But not this one. This one we saw coming. Here's the thing that makes this story different from almost every other rock that's fallen from space. This asteroid was spotted while it was still out there, hours before it hit. It was picked up through a telescope at the Konkoly Observatory in Hungary by an astronomer named Christian Sarnecki. At that point, it was just a faint moving dot against the stars, one of countless objects the sky is full of. But this one was on a collision course. Once it was flagged, the systems built for exactly this moment took over. NASA runs one called Scout. The European Space Agency runs one called the Meerkat Asteroid Guard. Their whole job is to take a newly spotted object, work out where it's going, and answer one question fast. Is this thing going to hit us? And an astronomer at NASA's Jet Propulsion Laboratory, David Farnokia, kept feeding in fresh trajectory updates as the observations came in, sharpening the prediction hour by hour. Now, think about how rare this is. Countless asteroids have struck the Earth over its history, and almost all of them showed up with zero warning. Humanity has only ever managed to catch a handful before impact. This was one of them, and it wasn't a vague guess. They knew roughly when it would arrive and where. Then, right on schedule, the fireball lit up the sky over Germany, exactly where they said it would. The prediction came true in the air, for everyone to see. But knowing where a rock enters the atmosphere is one thing. Working out where the actual pieces come down is a completely different problem. Because from the moment that fireball goes dark, everything changes. Once the fireball burns out, the rock isn't a streak of light anymore. It's just a dark stone falling through the night, and it's almost impossible to see. Working out where those pieces land fell to a team of Czech astronomers, Pavel Spurný, Jiří Borovička, and Lukas Šebení, from the Astronomical Institute of the Czech Academy of Sciences. And the phase they had to model has a name. It's called dark flight. Think about what's actually happening up there. The fireball ends while the rock is still high in the sky. From that point on, it's no longer glowing, no longer moving in a straight, fast line. It's just falling, slowing down, and getting pushed sideways by the wind the whole way to the ground. And the wind up there can be strong. So the same rock, dropped from the same point, could end up in very different places depending on how hard it was blown off course. The Czech team took all of that and modelled it, tracing where the fragments most likely came to rest. But they noticed something else, too. Looking at the light the fireball gave off as it burned, they suspected this might not be an ordinary space rock at all. They thought it could be a rare, enstatite-rich type of meteorite, something you almost never get to hold. Hang on to that, because it matters later. When they were done, they had a prediction: a stretch of open farmland just south of a village called Ribek. So now there was a target. But a target isn't an X on a map. It's a scatter of small, dark rocks spread across cold, open fields. And somewhere in all of that, the real hunt was about to begin. This is where a meteor astronomer named Peter Jeniskens comes into the story. He works at the SETI Institute, and when he heard where this rock had come down, he got on a plane in San Francisco and flew halfway around the world to a field in Germany. And here is the thing about Jeniskens. This was not his first time doing this. It was his fourth. He had guided a recovery like this in Sudan back in 2008, in Botswana in 2018, and in France in 2023. Each time, a small asteroid spotted before impact, and each time, a search on the ground to find what was left of it. This is a man who has quietly made a career out of chasing rocks that were seen falling from space. On the ground, he teamed up with Lutz Hecht from Berlin's Natural History Museum, the Museum für Naturkunde, and between them, they pulled together a proper team. Students and staff from the museum, from the Freie Universität Berlin, from the German Aerospace Center, and from the Technical University of Berlin. A whole group of people out walking a stretch of winter farmland looking for dark stones. And think about what they had going for them. A world-class prediction of exactly where the pieces should be. A search area mapped out by some of the best people alive at this. And a team of experts on the ground, walking that zone with the best directions anyone could possibly ask for. Everything was in place. The rock had been caught in space, tracked to the ground, and pinned to a specific patch of German soil. This should have been the easy part. It was not. So here's the part that doesn't make sense. With all of that going for them, the team walked those fields and found nothing. Perfect prediction, expert searchers, the pieces almost certainly right there under their feet. And they still couldn't find a single one. To understand why, you have to know how meteorites are normally spotted. Most of them are easy to pick out because of one feature. As a rock tears through the atmosphere, the outside melts and cools into a thin skin of black glass. That dark, burnt crust is the giveaway. It's the thing that makes a meteorite look like a meteorite and not like every other stone in a field. But these ones didn't have that. Instead of a black crust, their outer layer was mostly see-through, a pale, glassy skin that let the rock underneath show through. And the rock underneath just looked ordinary, grey, plain, exactly like the countless normal stones already scattered across German farmland. Jeniskens put it well. From a distance, he said, they were devilishly difficult to find because they looked like any other rock lying on the ground. Close up, not so much, but you had to get close up first, and that was the whole problem. Sit with how strange this is. Every hard part had already been solved. A telescope caught the thing in space. Machines tracked it. Astronomers modelled exactly where it fell and walked people right to the spot. And then the entire operation stalled, not because the rocks weren't there, but because human eyes couldn't tell them apart from ordinary gravel. They didn't need better coordinates. They needed someone to teach them what these things actually looked like. That someone turned out to be a team of meteorite hunters from Poland. These are people who do this for the love of it, who know what a strange rock looks like better than almost anyone, and they were the ones who found the very first fragment. That single find changed everything, because now there was an actual example to hold up and say, this is what you're looking for. This is what one of these looks like sitting in the dirt. And the moment the team's eyes were calibrated, the whole thing flipped. The field that had given up nothing started giving up piece after piece. Two students from the Freie Universität, Dominik Dieter and Kara Weyer, were among the first from the group to find fragments once they knew what to look for. Another student, Laura Kranich, recovered a piece out near the village of Ribbeck. What had felt impossible an hour earlier was suddenly happening again and again. Same fields, same rocks, same people. The only thing that had changed was that they finally knew what these things looked like. And once that clicked, the recovery rolled on through the days that followed the fall, fragment after fragment coming out of that cold farmland. It's a strange thing to watch a search go from hopeless to almost easy in the space of a single discovery. But that's exactly what happened here. The hard-won prediction had put them in the right field. The Polish hunters had shown them the right rock. Now all that was left was to gather the pieces up and find out what they'd actually been chasing this whole time. So what were they? A fragment went back to the lab at the Museum für Naturkunde and was put under an electron beam microprobe, an instrument that can read exactly what a rock is made of, and the answer confirmed what the Czech astronomers had suspected from the fireball's light all along. This was an Aubrite, a rare kind of meteorite, and one of the hardest of all to spot on the ground. Now here is how rare we are talking. Of all the meteorites that have ever been seen to fall and then recovered, only 11 other falls of this type existed in the world's collections before this one. 11. On the 2nd of February 2024, the find was submitted to the body that officially names these things, the Meteoritical Society. And the name itself reaches back nearly 2 centuries. Aubrites are named after Aubries, a place in France where one of these fell on the 14th of September 1836. The museum in Berlin still holds a fragment of that very fall. 2 rocks, the same rare type, separated by almost 200 years. And the scientists there described exactly why these things are so good at hiding. They look like grey granite. They are made mostly of 2 magnesium silicate minerals, enstatite and forsterite, and they contain almost no iron. No dark metal, no black burnt crust, nothing that screams meteorite. Just a pale, plain, granite-looking stone lying in a field full of pale, plain stones. Which is the whole reason the search stalled the way it did. The rock that was almost impossible to find turned out to be one of the rarest things you could possibly find. Step back for a second and look at the whole thing. A rock drifts through the solar system for billions of years, going nowhere in particular, seen by no one. Then, in its final few hours, a single telescope in Hungary catches it as a faint moving dot. Machines built for exactly this moment lock on and work out where it's going to hit. Astronomers trace its path all the way down and pin it to a stretch of farmland outside a small German village most people have never heard of. And then a group of people walk out into the cold and find it by hand. Think about everything that had to come together. A rock spotted in space in the narrow window before it struck. A trajectory tracked by machines and sharpened hour by hour. A fall zone modelled down to the right fields. An international team on the ground, pulled together from 4 countries. And one lucky break, a team of Polish hunters who found the first piece and showed everyone else what they were looking for. Take any one of those away, and those fragments are still out there in the dirt right now, mistaken for ordinary stones. Instead, they became one of the rarest meteorites ever recovered. A type only seen to fall a handful of times in all of recorded history, nearly invisible on the ground, and found anyway. And that streak of light that flashed across the sky west of Berlin the one thousands of people filmed and then scrolled right past, turned out to be something extraordinary. One of the most completely documented asteroid falls that has ever happened. Watched from space, all the way to the ground.